Welcome back, geometry. We are still in section 7.4. We're going to talk about rectangles and some little nitty-gritty stuff about them. So turn with me to page 391 and copy down theorem 7.13, the rectangle diagonals theorem. I started drawing it out as well. You can draw the rest with me. And then we're actually going to go back to the textbook online, at least in my version. You should have your textbook open so that you are not flipping through screens. And also the physical textbook's just nicer to read. Okay, so theorem 7.13, this could be a rectangle, who knows? So a parallelogram, all right, so we know it's a parallelogram, right? Opposite sides are parallel, is a rectangle if and only if, okay, so we already know some stuff about the sides and the angles, if and only if the diagonals are congruent. If and only if the diagonals are congruent. So make sure you write that down, that we know that AC has to be congruent to BD for this to be a rectangle. And a nice little, by the way, BT dubs, the diagonals bisect each other. So this part is congruent to this part is congruent to this part. So even though AC is congruent to BD, we also know that each of these little parts are congruent to each other because they bisect, they split each other in two, they bisect each other. Okay, I actually want to take a look at example 4 together. So let's take a look at my online textbook. The nice thing about learning, no, maybe not the nice thing, but the great thing about learning geometry is that you really are learning logic. How do you know what you're looking at is something? Can you assume that it is? Why or why not? So here we have example 4. And so we're going ahead and we're building a frame for a window. All right. This is actually great because the house down the street is currently under construction, and I watched them, well, I guess I didn't watch them make the windows, but I saw them dog walk after dog walk, putting the window frames in and then eventually putting the windows in, right? Little by little, I saw the progression. So we know this about the window: 33 inches on top and bottom, 44 inches left and right. So what do we know? The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Okay, so we know we need to make the opening a rectangle, but knowing that opposite sides are congruent, can we say it is definitely a rectangle? And of course, we can look at the solution. No, we can't, right? While it looks like a rectangle, we don't know for a fact it's a rectangle because we don't know what about the angles. We don't know that they are 90 degrees in every corner, okay? What about part B? We measure the diagonals of the opening. The diagonals are 54.8 inches going, one way and 55.3 inches going the other way. What can we conclude about the shape? Well, according to the rectangle diagonals theorem, we know that it's not a rectangle because 54.8 inches is not equal to 55.3 inches. And okay, so we still know it's a parallelogram is all I was going to say. The diagonals of the quadrilateral formed by the boards are not congruent, so the boards don't form a rectangle. So we know it's not a rectangle because those are different, okay? Now let's turn the page to 392 and take a look at the top. So suppose we measure the diagonals, you measure only the diagonals of the window opening in example 4, and they have the same measurement. So can we conclude that the opening is a rectangle? All right, so you measure it, you know that the diagonals are the same. Can you conclude that is it a rectangle? I'm going to have you answer that on the Ed puzzle. All right, now I'm going to do some math with you. Number 7. I'm going to switch back to my notebook. You can copy down number 7 and also look at example 5 with me. So this is page 392, number 7. All right, in example 5, QS is equal to 4x minus 15, and RT is equal to 3x plus 8. We want to find the lengths of the diagonals for the for QRST. Okay, so I need to go back to page 391, take a look at example 5. All right. Okay, so we know that we have a rectangle QRST, and it has diagonals. All right, so they give us different measurements for the diagonals in example 5, but they're telling us to now find it if this is the measurement of QS and this is the measurement of RT, and they do tell us that it is a rectangle. So we now know that we can say that 4x minus 15 is equal to 3x plus 8. What am I going to do? I'm going to solve for x. So let's move all the x's to one side. Let's move all the constants to the other side. So notice, again, this is for those of us that are still not confident in our Algebra 1 skills. The idea is to move like terms to one side and, well, everything else to the other side. So pick a side. So I picked the x's over here. So what do I do to get them over there? I have to do the opposite operation. Likewise for the constants, okay? So if you're stuck with the minus 3x on both sides, the plus 15x on both sides, don't think about it math-wise. Think about it, what's the goal? The goal is to get the x's. How do I cross the bridge? I have to do the opposite. So 4x minus 3x is 1x. I'm reading left to right here, but you can do it in any order. Negative 15 plus 15 is 0. That was the point. 3x minus 3x is 0. That was the point, moving the 3x. And then 8 plus 15 is, well, what would that be? 23. So x is equal to 23. And again, this was the point to get all the constants over there. Now it's just, gives you a different viewpoint than maybe your Algebra 1 teacher taught you. All right, so we know x, but we did not answer the question because I believe, and I'm going to look back at the textbook, which you should always do, find the lengths of the diagonals. So x is wonderful, but that's not what we're looking for. Now we just pick which one do you want to use. I'm actually going to plug it into here. I feel like I don't want to do subtraction. I also know that I can do 3 times 2 and 3 times 3 in my head and not have to carry anything over. So 3 times 20 is 60 and 3 times 3 is 9. So 3x is 69. And then we have to add 8 and that would be 77. So RT is equal to 77 units, which is also equal to QS. So the length of diagonals are 77 units. Okay. All right. You're going to have some more problems to do later on, and we're going to do a few activities together in groups in class.